So today we're going to put numbers back on our graphs, and we're going to work with what I view is probably the most important graph in the real world. It's called a scatter plot. Constructing a scatter plot is going to feel really like normal, comfortable. We've done graphs, so that's going to feel normal. Um, we're going to talk about interpreting the data that's on the graph, and we're going to talk about drawing something called a trend line or a line of best fit. Constructing the scatter plot, like I said, will be very similar to what we've done, but the difference is going to be that your data points don't necessarily all fall in a perfect straight line. And in the real world, things rarely come to a perfect sort of straight line when you're gathering data. So if you turn to page 666, let's first talk about what is the term scatter plot even mean. A scatter plot will have two different variables, just like we've done, a y and an x, and it will plot them on the same graph, and it's called by, which is a prefix meaning to, variate, again, varying data on that graph. So a scatter plot shows, is there a relationship between two sets of data or not? And we show that by ordered pairs on the graph that will represent one of the sets of data. In this case, it's television ratings. Look, there's Mr. Yuck, no graph. But it's like a certain season of a TV show and how many millions of people watch it. So in the first season, 31.7 million viewers watched it. And the question is there a connection as the seasons go up? Are we seeing some kind of connection to how many viewers are watching it? So that's what the scatter plot is going to show us. So on the x-axis, that's our independent variable, that's the season, and then viewers in millions will be our y, because the number of viewers depends on which season it is, not the other way around. So that's why viewers is your dependent variable and season is your x. And then we basically set the scales. Notice they're going by ones on the x. And over here, notice they put a break in the graph and started at 20 million because there's no number below 22. So if you didn't put that break, you'd have like all this blank graph underneath, and the graph would be way up in the, way up on its own. So that's why there's a break in the graph. And then you plot the points. So here's season 1, and it's right below 32 million, like at 31.7, season 2, and all the way down. You do not connect the points on a scatter plot. We'll talk more about that in a second. And the coordinates of each point are the numbers that go together. So the season 1 goes with that just below 32 million viewers. So what I want to do is let's first start by connecting our own. So on page 666, you're going to construct a scatter plot, and it's going to be the weight of an alligator at various times after hatching. So you have an alligator that hatched, at the zoo, and they're trying to keep track of what's going on with this alligator's weight. Now notice we have weeks, 0, 9, 18, 27, 34. Don't quite make it up to a year old because that would have been 52 weeks, okay? And then they're weighing the alligator, and they're keeping data as to what weight it is in pounds. So first of all, you would have to decide who's X and Y. We've done that a lot. The weight is going to depend on the weeks. And then we're going to plot and put our title. So I'm going to ask you to stop and go ahead and graph this one, and we'll come back and talk about it on page 666. If you don't have your book, you just need a piece of graph paper. All right, so again, we're going to be smarter than the book, and we're going to put a title in. They don't ever leave room for it. And this should have been the number of weeks, because the weight in pounds will depend on the weeks. Your calendar is not going to change depending on the alligator weight, but the alligator's weight will change as time goes by. And then they very nicely set the scales for you here. So, 0, 6 would kind of be where he started. And then we would go over to 9 and about 8.6. And then you should see a graph that looks like this. And there is a scatter plot. Notice the points don't all lie perfectly on a straight line, although they are pretty close. They don't need to be. And that's what we're going to talk about next, is interpreting a scatter plot. But that's basically how you make one, and it kind of feels like stuff we've done before. So on page 667, we talk about correlations or associations. Those are synonyms. So how do another word would be connection. Do the two data sets connect? So there are three things that you're going to look for at the start here under correlation. Now what you're going to see is my cursor, and notice I'm tracing the data, and do you see that it goes up like a positive slope? You see that? Well, that's called a positive association. As the x increases, whatever this data is here, the y is also increasing. That's called a positive correlation, a positive association, a positive connection, however you want to say it. Notice this time, as I go left to right, I see like a negative slope, right? That's a negative association, a correlation or connection. As the x increases this time, the y is going down. There's still a connection, but this time it's going down. The third case is a hot mess. Like you can't even draw a line here. There's no pattern, which says there's no connection between whatever data set we're talking about. So if we go back to our alligator, do you see a positive correlation? There is a positive connection between his weight and the number of weeks that have gone by. After, if you determine there's a correlation, now if you say no correlation, none, you're done. But if there is a correlation, the next thing you ask yourself, step 2, is does it seem to be linear? Could I put one single line sort of through the center? Or is it nonlinear in that it has more of a curve pattern to it? So you're going to talk about linear versus nonlinear. So linear, the data points close to a line, and nonlinear, the data points lie in a shape more of a curve. Finally, the third thing we're going to look for, step 3, after we determine positive, negative, after we determine linear or nonlinear, we're going to look for something called a cluster, which is a group of data that's all sort of tightly packed more than the rest of the data, and something called an outlier. And an outlier is a piece of data that's just, hanging out, waving at you way away from all the other data. So if I look at this scatter plot, it does go up to the right. So I would say it's a positive association or correlation. To me, it has more of a curve. So I would call it a non-linear. And then there is a cluster, and I put like an oval, an ellipse around them. And then outliers up here waving. So this data would be positive, looks to me more non-linear. There's an outlier and there's a cluster. And that's how we interpret a scatter plot. So if we take a look at this example 2, this is the cost in dollars for a memory MP3 player. Oh my gosh, like a digital, we have them all on our phone now, but used to have these little devices that you could have music on. But anyway, whatever it is, you could just replace that kind of with your phone instead of that MP3. So the cost depends on the memory, right? How much depends on what size memory you get. And so you have to now interpret it. And they have these words over here, variable linear. I'm not worried about you knowing that. I'm just worried about you understanding what you have to do. 3 steps. Positive or negative. That's the first one, or none. And if it's none, you're done. But here, it seems to be as the memory is getting bigger, the cost is going up. So it's a positive correlation. The next thing, it does seem to be linear, although this piece right here seems to be showing that it's tugging up. But right now, for the most part, it is linear. You just see me putting ish because I'm kind of wondering what's going to happen, down the road here. Is there a cluster? And you'll see an oval around that cluster that seems in the 1 to 2 gigabytes. There seems to be a cluster of price. And the book just says it doesn't appear to be an outlier, but I'm just kind of questioning that. And if you said, you know what, I think that's an outlier, I would go with it, and because I just don't know what's going to happen next. So I'm kind of going, maybe, like that could be an outlier. So I would kind of accept either way there. So now it's your turn to interpret the scatter plot, and the video will stop on B and ask you about correlation, linear or not, and clusters and outliers. I'll come back in a second and see how you did. So did you say negative? And do you see that it's pretty much a line? So this would be a negative linear correlation. And I'm not seeing any clusters and I don't see any outliers. How about in C? Did you say this is a hot mess and there's no correlation? So when you say none, you're done. You're not going to do anything else beyond that. Okay, so if we look at page 669, there's a public school enrollment. So this is the number of students in millions in the school system. Now, you can see the Mr. Yuck that we are starting to become familiar with, that they don't put the title on the graph, but you're going to notice sort of, what's this other Mr. Yuck doing here? This graph is a really hard one to read because it's the years since 1999. So if you go to 0, that's your start year. That would be 1999. And if you go over 1 year, that would be 2000. And this 2 would be 2 years after 1999, which is 2001. And I just absolutely hate this scale. I want 0 to be 2000. And so it's a very hard scale to read. Now, why would they do that? The only thing I can figure is, they started gathering data in 1999. So that's why they're making it at their year 0. But it's just, I put Mr. Yuck here. You got to be careful watching these scales, okay? So just understand that when you get to 10, that's 10 years after 1999. That would actually be 2009. So that's why Mr. Yuck's here. So anyway, you'll see the title, you'll see the labels, and then you notice there's a break in the graph because the smallest number is 46.9. So there's a break to start at 46 million. Labels, everything great here. And then we plot the points. Notice they're not in a perfect straight line because the data isn't perfectly linear, but it does show a positive. It is close to linear. I don't see any clusters. I don't see any outliers. And that's how, again, we interpret a scatter plot. Now, how can we use scatter plots to see what's going to happen in the future? That's what we're going to talk about now in what's called a line of best fit. And you're going to hear me call it a trend line because that tends to be the words that are used out in the real world as well. So on page 678, we've got a scatter plot. Mr. Yuck's coming in to, tell you there's no title. Now look here, this is so much easier, years after 2000. So 0 is 2000, 2001 is kind of midway, 2002, just an easier scale to read. And then it's the cost of cookies as we go across the years after 2000. So again, 9 years after 2000, this would be in 2009, cookies were costing $3.24. Notice the scale is going to fit, get up to 9. So they're going kind of weird rectangular blocks here. They left the kind of the middle line out, but they're going 2 blocks to 1 line. And then as we go up, they again have a break, which they didn't mark, but they're starting at 2.4 and going up to 2.5 and going up. So this is priced by 50 cents, basically. So this would be not by 50 cents, 5 cents. So this would be $2.65, $2.70, 2075, 2080. They plot. And now what you do to make a prediction of what the cost is going to be in 2013, which is really 4 years after your data stops, you draw what's called a trend line. So you trace the data and you have to put a line down the center. So notice that there's 4 points above the line and notice there's 5 below. And I'm kind of tracing how the data is moving. And then I put my ruler down. Now the rulers at school are clear, so you can still see the points underneath. If I didn't have a clear ruler, my crazy idea is to get out a piece of dried spaghetti because it's really thin and it won't cover up any of the points, and you can kind of lay it in the middle and use that to draw your line. So if you're at home and you're making a scatter plot, you can do that. Once you've drawn your trend line in, you can now use it to make a prediction. So what's going to happen in 2013? Well, there's 2012, 2013. I'm going to come up, I'm going to hit my trend line, I'm going to go over, and it looks like $3.35 per box. So just understanding that a line means a line, a curve is never a line. So when you say you would never call this a line. So in mathematics, line means straight. There's no such thing as a curved line. If the trend is not straight, you would draw a curve, not a line. And this year, we won't be talking about how to make predictions. off of a curve. You do that in algebra, but we will be talking about in our next video, what can we do with this line as far as making predictions way off the graph. If your trend is not straight, you draw a curve, not a line. And weirdly in math, a line is considered to be under the heading of a curve, but a curve is not really under the heading of a line. Rarely do you see that. Okay, so one more here, and then we'll have you do one and call it a day. So this is the public school enrollment there that we were kind of talking about, and that's silly years after 1999. But if you wanted to make a prediction about what's going to happen in 2015, oh, by the way, 16 years after 1999, you would take that data and you would draw a trend line down the center. Now, your trend line does not even have to touch a data point. It doesn't have to go through a data point. Pretty, going to go through a lot here because the data is so tightly packed. But that's my trend line, and I extend it way out. And if I come out to 16, which would be 16 years after 1999, which is 2015, I would go up and hit the line and come over and say, well, about 51.5 million kiddos, we better plan for that. We better, figure out how we're going to be able to afford that in our country. So last one here for you, page 670, you're going to interpret that scatter plot that's shown. So the first thing that you need to do is you're going to make, you're going to interpret it. So you're going to positive or negative, and if it was none, you'd be done. And then you're going to talk linear or not, and you're going to talk clusters or outliers. Now, this is the men's 100-meter freestyle, which is a swimming race. In the Olympics, the Olympic size pool is 50 meters. So this is the race where you would go down, touch the wall, and come back. You're done. It's a sprint race, a swim sprint race, basically. And what you notice is that down here, notice 1952, and then there's 2 blocks for 1960. What is missing is the Olympics happen every 4 years. So, this would be 1956, and then 4 years would be 1960, and 4 years would be 1964. So when you get up here, here's 2000. The next line would be 2004, 2008. 4 years would be 2012. 4 years would be 2016. So every 4 years, because that's only when the Olympics happen. So once you've done that, describing, interpreting the scatter plot, you're then going to put in your trend line. You're going to extend the line to make a prediction of what do you think the time was in the 2016 Olympics. The video is going to stop. I'm going to let you do that. And we'll come back and check out how you did. So basically, guys, this talks about everything that we have covered in this video. Mr. Yuck's there because of the missing title. And you should have said that it is going down. So did you say it was a negative correlation? It's mostly linear, right? And also there are no clusters and no outliers. Did you draw a trend line? Now notice, and my trend line does hit a couple of data points. It doesn't have to, but you'll see that, it's through the center of the data. Now the data started to look kind of curvy. That's why I said mostly linear, but then it came back up. So I can kind of draw a trend line through there, right? And then I extended it out to hit, and I'm getting a time just below 46 seconds, right? So I'm going to call it 46 seconds, but it's just below that. And that's how I use that to make a conjecture, or prediction is the same word. This has already happened, right? 2016 Olympics. So how good was this prediction? Because it's historic, I went out and checked. So I went out to the internet and I found out that in 2016, Kyle Chalmers won the race from Australia at about 47.6, which you'll notice is higher. I put his time up here than our prediction. And here are the silver and the bronze, which were, look at not a big difference there. This is seconds, right? Barely a difference of seconds there, part of the second. This is 5 100ths of a second more. Can you imagine? So anyway, why was our prediction off? Why didn't they race, closer to that 46 seconds? Well, my question to you is, will this trend happen forever? And think about it. You got to swim down the pool and back. Isn't it true that at some point, somebody's almost going to own the record? Like, you can't swim any faster. You can't make it down and back in 12 seconds, right? Without a motor. So what is happening is they're starting to time, like people are winning by a thousandth of a second or four thousandths of a second. So as far as we can measure time more accurately, we are getting that, but this is going to level off. And is that process already starting, right? So today we talked about scatter plots and how they're useful in the real world and comparing two sets of data. We talked about interpreting them, and there's three sort of steps to that. You first to determine if there is a correlation. If you say none, you're done. But if it's positive or negative, you can go to the next step, which to talk about is it linear or nonlinear. And then finally, are there clusters or outliers? And that's how you interpret a scatter plot. To use the scatter plot, you put in a line of best fit or a trend line to run down the center of the data if there is a correlation to be able to extend out and make predictions. And that's what we've done in this last Olympic example. So when we get to class, we'll do some practicing together and talk a little bit more about scatter plots, but they are an extremely useful graph in the world to see if things are connected or correlated. I'll talk to you soon. Have a great day.